Welcome back. Welcome back. Trig Bootcamp Part 3. Quadrantal angles. Angles between quadrants. Okay. I'm going to make this as simple as possible. Okay. So the idea is this. Okay. If you think about a small angle and then letting that angle sort of, I don't know, check this out. Look here, I'm adjusting this angle right here. So here's a 45-degree angle. This is where the x and y components are going to be the same. Okay. Now, if I go down here like this, look at what's happening. The angle's getting smaller and smaller and smaller. As the angle gets smaller, the opposite side gets smaller. Let me show you what I'm talking about. So here's kind of a small angle, and the opposite side is that one. Okay. Now let me change my color, and I want to show you what happens if I keep the R. If I keep the R the same, so here's the R. Now if I keep that the same length, but I just make the angle smaller, look at what happens to the opposite side. Okay, smaller angle produces a smaller opposite side. Okay, so you know it should hopefully at this point be kind of easy to imagine that if I have an angle along the x-axis, that my opposite side will be exactly 0. Okay, so that's the topic of discussion of this video. Okay, so now that we sort of know what we're talking about, let me draw this angle here, 0 degrees. Okay, now like we were just saying, all right, as far as triangles are concerned, there's no opposite side here. Okay, so the opposite is equal to exactly 0, which again means my y component is exactly 0. Okay, so this is how 0 degrees is handled. Okay, now no matter what, we have the Pythagorean theorem, x squared plus y squared equals r squared. All right, now if the y, if this is 0, which is the case for 0 degrees, if this is 0, then I get x squared equals r squared. Okay, and if I solve for x, I get that x equals plus or minus the square root of r squared, which is plus or minus r. Okay, and so what this means is this. It means that there's two angles that have a 0 for a y component. One angle is 0 degrees. The other angle is 180 degrees. If I draw an angle here along the negative x-axis, then we can see, hopefully we can see, that the y coordinate is going to be 0 as well. Okay? So good. And yeah, excellent. So look here. So for 0 degrees, the x coordinate is exactly the same as r. Okay? The y coordinate is exactly 0, and the r is literally just whatever r is. Okay? So again, here's my x component, here's my y component, here's my r component for 0 degrees. Okay? So this is all the information I need to write down sine, cosine, tangent, secant, cosecant, cotangent. All right? Sine of 0 degrees or 0 radians is the same thing. That's the y component of the r component. That's just going to be 0 over r, and 0 over r is just going to be 0. Okay? Cosine of 0, well, that is x over r. Okay? And x over r, that's just going to give me r over r, which is 1. So cosine of 0 is 1. All right? Tangent of 0. Well, that is y component over x component. Y component is 0. X component is whatever r is. 0 over r is 0. Okay? So there's that. All right? Let's write down the rest of them. Secant of 0. Secant is the reciprocal of cosine. R over x. And look, they're both r. Reciprocal of 1 is 1. We knew that. Cosecant of 0. Well, that's the r over the y. And we get whatever the r is over 0. So that is undefined, ladies and gentlemen. U for undefined. Okay? And that should help us understand what the cotangent of 0 is going to be. That's just going to be x over y. But again, the y is 0, so I get whatever the r is over 0, which again is undefined. Okay? So there we go. 0 degrees done. All right, now let's turn our attention to 90 degrees. Okay? So now let me make my XY grid. X, Y, and let me draw a 90-degree angle. Okay? So okay. So really quick, before I just jump straight in, let's think about this angle here, really close to 90, but not quite. Think about this side. Think about the x component. It's going to be really small, so that whenever I draw a perfect 90-degree angle, there's actually going to be no x side at all. All right. So, oops. So if I draw a 90-degree angle, it's going to be straight up in the air like this. And once again, the adjacent side, which is like the x component, that's going to be 0. And a way to think about that is just think about this coordinate here. Think about this point. This point's on the y-axis. The x-coordinate of this point is exactly 0. Okay? So, x component 0. And just like before, we still have x squared plus y squared equals r squared. If x is 0, that means that y squared is r squared, which means that y, just like before, is plus or minus r. Okay? And so one of these is going to correspond to this angle. The other one's going to correspond to this angle down here. Okay? Good. So let's write down our components for 90 degrees. 90 degrees is going to have the following components. As we said, x component is 0. Y component is going to be positive r. And then the r is just whatever it is. Okay? So this gives us the information we need because the cosine of 90 degrees, or cosine of pi over 2, is going to be the y component over the r component. Oh my goodness, and I messed it up. So sorry everybody. Cosine is x over r, not y over r. So it's going to be 0 over r, which is 0. Okay. Sine of 90 degrees. That's going to be y over r, which is, so y is positive r over r, and that's 1. Okay. Tangent of, and I'm going to write pi over 2 here. Pi, because remember, pi is 180. 180 over 2 is 90. Okay, so everyone should be used to degrees and radians. So tangent is y over x. And so we're going to wind up with r over nothing. And that is, of course, undefined. Okay. Secant of 90 degrees. Well, that's just the reciprocal of the cosine, r over x. And the r is r, and the x is 0. You divide by 0, you're undefined. Let's see. Let's do the cosecant of 90 degrees. That's going to be the r component of the y component. R over y, that's just going to be r over r. That's 1. Okay, and last but not least, the cotangent of 90 degrees. Okay, that is x over y, which is 0 over r, which is 0. All right, so there we go, everybody. There's 90 degrees, completely handled. Every trig function written down. All right. So now I'm going to come back up here. Well, okay. I guess I keep going down. 180 degrees. $180 degrees. 180 degrees points in the negative x direction. Okay. So this is 180 degrees. Okay. So if we look here, we can clearly see x is negative. We can clearly see here, this point here, the y is 0, and of course r is always positive no matter what. Okay. Once again, we have Pythagorean theorem, x squared plus y squared equals r squared. Y is exactly 0 for 90 degrees, so we get x squared equals r squared. And here we get x equals plus or minus r if we take a square root. And we know that x has to be negative, so we're talking about x is negative r for 180 degrees. Okay, so 180 degrees, if I list the components, the x is negative r, the y is 0, and r is just whatever it is. Okay, so again, x, y, r. Using that, we can write down the sine, cosine, tangent, secant, cosecant, cotangent of 180 degrees. So the sine of pi, because again, pi is 180, that's y over r. Y is 0, so we get 0. The cosine of pi, 180 degrees, is x component over r component. And here, x is negative r over r. Negative r over r is negative 1. The tangent of pi, well, that's the y component over the x component. And the y component is 0, and the x component is negative r. And that's just going to give me 0. Let's see, the cosecant of pi, you might be able to guess it, r over y. And the r, of course, is whatever it is. The y is 0, so it is undefined. Okay. The secant of pi, well, that's r over x. And then r is whatever r is. Then x is negative r. R over negative r is negative 1. And then finally, the cotangent of pi. Cotangent, well, that's just going to be x over y. And, the y is 0, so I get negative r over 0. So the cotangent is just going to be undefined. Okay? So there we go. There's 180 degrees in all its gory detail. Sine, cosine, tangent, secant, cosecant, cotangent. Done. All right. Now, the final angle of this video. 270 degrees. So 270 degrees points straight down. So again, imagine a point here. And if you think about this point, the x-coordinate of this point is 0. We can see that y is negative, and of course r is always positive. Pythagorean theorem, x squared plus y squared equals r squared. X equals 0, so y squared equals r squared. Take a square root, y equals plus or minus r. And in this case, it's going to be the negative of r because we know that y has to be negative. Okay. And so for 270 degrees, we're talking about the following components. X is 0, y is the negative of whatever r is, and then r is just r. Okay, so finally, we get the sine of 270. 270 in radians is 3 pi over 2, by the way. Because pi over 2 is 90, 90 times 3 is 270. Sine of 3 pi over 2, that's just going to be y over r. And that's just going to be y is negative r. So I get negative r over r. Negative r over r is negative 1. Cosine of 3 pi over 2. Well, the definition of cosine is x over r. And x over r is going to be 0 over r, which is just going to be 0. Tangent 3 pi over 2. Well, that's going to be y component over x component. That's going to be negative r over 0, and that's going to be undefined. All right, 3 more. Cosecant of 3 pi over 2. Well, that's r over y. So r over y, r is r, y is negative r. Divide these two, you get negative 1. The secant of 3 pi over 2. Well, that's going to be the r component of the x component. R component is just r, x component is 0, so we get undefined. Last but not least, the cotangent of 3 pi over 2. That's the x component of the y component. And that's going to be 0 over negative r, which is 0. Whew, okay. So there's that, 0, 90, 180, 270. That's all the quadrantal angles, okay? 360 degrees is exactly the same as 0 degrees as far as trig functions are concerned. Okay, and then the same is true for, 90 plus 360 is the same as 90, 270 plus 360 is the same as 270, so on and so forth. So there we go. There's all of the quadrantal angles covered in detail. Okay. So there we go, everybody.